All right, in this video, we are going to look at some standard ways to draw angles and what standard position means when drawing an angle. So here you'll notice we've got three different degree measurements, and we're going to go, before we do that, I want to take you to the class journal and look at one of the core concepts. So here's the requirements for an angle to be in standard position. So we're going to draw all of these in the coordinate plane, which means we're going to start out with our XY axis, and we're going to draw our angles on here. Now you'll see an angle can be formed by fixing one ray. Now a ray is just a line coming out from the origin with an arrow at the end. So fixing one ray, which we call the initial side, and rotating the other ray. So our initial ray is going to be fixed at the origin, and it's going to lay down on the positive x-axis. This is what's required for an angle to be in standard position. You'll see right here, an angle is in standard position when its vertex is at the origin and the initial side lies on the positive x-axis. Okay, so to measure an angle, you take your first ray or side, lay it on the positive x-axis. Your second side, the terminal side, is going to rotate around as many degrees as required for the angle. So you'll see, if we take one full rotation, if we start here and we start rotating around, when we're facing straight up, that's 90 degrees. Another rotation, we get to our negative x-axis, that's 180. If we keep going, that's 270 degrees. We're facing down. And the final 90 degrees, that's 360 degrees. So you see, we have the ability to rotate a full 360 degrees around our origin. Now, again, the keys here are to remember the initial side is the side that lays fixed on the positive x-axis. The terminal side is the other end of your angle. That's going to actually designate how many degrees you've rotated. Now, if you go back, you'll see that you can have degrees, you can have angles that measure more than 360 degrees, less than 0, so you can have negative. I'm going to show you what all of these look like to actually draw them. Okay, so for 240 degrees, what we're going to do is we take our initial side right here. So our initial side is going to lay flat. And then to measure out 240 degrees, you're going to see it's more than 180 but less than 270. So we know that the terminal side is going to rotate. It's going to go all the way around past 180, and it's going to go 60 degrees further than that. So about 2/3 of the way to your negative y-axis. And that's when you're going to draw your other ray, your terminal side. Now, you always draw this, the little semicircle, with an arrow at the end showing which way your angle opened. So this whole measurement right here would be 240 degrees. Now, this green 60 is just showing you that it went 60 degrees past. So here, the initial side is on the x-axis, and the terminal side is in quadrant 3. Okay? Now, 500 degrees. Let's look at what this looks like. Now, remember, if we take our angle and we rotate around a full 360 degrees, we're back at the positive x-axis. Well, to do an angle that's more than 360, we just simply continue on. So 360 plus 90 is 450. So we know that this angle is going to be about 50 degrees more. So just a little bit more than halfway into our second quadrant. So you're going to see our initial side is on the x-axis and our terminal side is in the second quadrant. And you'll see when we look at that, notice you have to draw the whole rotation so you get this spiral that's coming out. Otherwise, if you didn't draw this rotation, this whole spiral here, you would have no way of knowing that this was actually 500 degrees. You wouldn't know that it had already gone around one full rotation. So when you're drawing your angles, you have to make sure you draw, the actual rotation itself. Here, our red circle, semicircle, shows us that we went around 240 degrees. Here, we went around 500 degrees. Okay, now for a negative angle, all we do is our initial side still lies on the positive x-axis, but instead of rotating counterclockwise, we're just going to go clockwise. So a negative angle is actually going to open down starting into quadrant 4 and move around clockwise. So you'll see negative 50, again, our initial side, because it's in standard form, is on the positive x-axis, and this one moves down and opens down 50 degrees. So this would give us our negative 50. So really simple to draw these angles. You need to make sure you remember the proper formatting, the rules that go along with this. So make sure you always have your initial side on the positive x-axis. For a positive angle, it opens counterclockwise, and you just rotate around the proper number of degrees. Remember, each quadrant is 90 degrees. So 90, 180, 270, 360. Okay? So obviously there's no way for me to have you guys draw these in the problem, so you're not going to have to do that. You're not going to have to draw these right now. But what I want you to do is I want you to tell me for A, B, and C, I want you to tell me what quadrant the terminal side of each angle will be in. So you've got 3 angles right here, 390, negative 160, and 690. What quadrant will the terminal side be in? So quadrant 1, 2, 3, or 4. Okay, go ahead and enter all 3 of your answers into the text box. Just label them A, B, and C, and tell me what quadrant the terminal side will be for each angle. Okay, for the next part, what I'm going to do is I'm going to show you guys another term that relates to triangles and angles. So let's go ahead and look at this problem right here. So find one positive angle and one negative angle that are coterminal with negative 45 and with 395. Okay, so the key word right here is coterminal. Now, an angle, a coterminal angle, what that means is if you look at an angle right here, if we take, let's say for example, we're looking at a 45-degree angle. Okay, so we start with our initial side, and 45 degrees comes right out here. So there's a 45-degree angle. Well, imagine if we had another angle that was 405 degrees. So again, let's lay our initial side out. 405, so that means we're going to go around 360 plus 45 more. So we draw our terminal side out. Here is 405. Now, if you look at both of these angles right here, their terminal sides are in the exact same position. In fact, if we graphed these both on the same plane, you would see that these terminal sides overlapped. That's what's called coterminal angles. Okay, so angles are coterminal if they're, when drawn in standard position, their terminal sides overlap. Okay, that's the definition of coterminal. Now, you can find coterminal angles by simply adding 360 degrees to an angle. You see 45 plus 360 gives us 405. So again, a coterminal means that the angles share the same terminal side location on your coordinate plane. So in order to get coterminal angles, you simply add or subtract 360 degrees from each angle. So there's an infinite number of coterminal angles. So an angle can have an infinite number of coterminal angles. So let's look at this. For part A, if we want to find one positive angle and one negative angle that's coterminal with negative 45, all we do is if we want a positive angle, we need to add a multiple of 360 so that we get a positive number. So if we take negative 45 plus 360, that gives us 315. So 315 would be a positive coterminal angle to negative 45. To get a negative coterminal angle, we simply subtract 360. Negative 45 minus 360 is negative 405. So these are coterminal angles. Now, when it says find one positive angle and one negative angle, that means find, an angle that has a positive sign and a negative sign that's coterminal. So sometimes you can't just subtract 360 and have a negative coterminal angle. Look at part B. We want to find a positive and a negative coterminal angle to 395. So the positive one's easy. If we take 395 and we add 360 to it, then we get 755. That is a positive coterminal angle. If we subtract 360, 395 minus 360 is 35. Even though we subtracted 360, that doesn't give us a negative number. So we have to subtract 360 again. So 395 minus 720 gives us negative 325. You see, if we just subtract 360, we're still left with a positive coterminal number. So remember, to get a coterminal angle, you add multiples of 360 to get you either your positive or negative number. Okay? So what I want you guys to do now is for each angle here, I want you to find one positive angle and one negative angle that's coterminal with each A and B. So you should have two answers for A and two answers for B. One positive number and one negative number for an angle that's coterminal for each of these. Go ahead and enter that into your text box now.